All right, so hello. So we are going to start our new topic, which is covalent bonding. And so how we are going to look at covalent bonding, because remember that in covalent bonds we share electrons. And so we're going to use something called Lewis dot symbols and structures to see how our covalent bonds share electrons. Right? And we're eventually going to get into something called the octet rule, which is going to guide how they're sharing. Okay? And so today is going to be just an introduction to these Lewis dot symbols. And so we're going to see there's going to be like 3 levels that we're going to do. So today we're just going to do them for individual atoms, and then next we're going to do them for some compounds, but that are a little bit simple. Okay? And then the last one is we're going to get into some more complex compounds. And so what a Lewis dot symbol is really just a diagram that uses our dots to represent valence electrons of a single atom. Okay? So it's a little bit similar to the shell model in that, again, our dots here are showing us what are the valence electrons. Okay? And so in order to be able to draw a Lewis dot symbol, you have to be able to know how many valence electrons are in an element. Okay? And so remember, that can be easily found using a periodic table without having to go through and draw out the entire shell model. Okay? And so how we can find it out is that our number of valence electrons is going to equal our group number. Okay? And so remember, our groups are our vertical columns. So if we were to look at the periodic table, so this is the one that you guys are using, okay? If we were to look, these top numbers here, okay, tell us what our group number is. So don't worry about this middle bit, okay? So we're not going to worry about them, but all the taller columns, so 1, 2, and then 3 through 8 here, so all the ones that have an A after them, are what we're going to use to find that pattern, okay? And so remember, these are just Roman numerals for numbers, okay? So this would be like column 3A. And so if our number of valence electrons equal our group number, and this is column 3, or group 3, then all our elements in this column are going to have 3 valence electrons. So for example, aluminum is right here. It's in our 3rd column, our 3rd group. So it has 3 valence electrons. And so that pattern, that trend goes throughout the entire table for these tall columns. Okay, so like oxygen is in our 6th group. Okay, it has 6 valence electrons. Okay? So it's as easy as that. It's almost like finding the ion charge, where all you have to do is you have to just find what column the element is in. Okay? And so before we actually draw the Lewis symbols, here is like a little recipe or a list on how to get you to actually draw them. So the first thing we want to do is write the element symbol. Okay, so whatever element we're given, we're going to write the symbol of it. And then you want to find the number of valence electrons. So again, we're going to do that using that really easy way that we just looked at. So this is going to make more sense once we actually start doing them, but we're only going to put the dots on the top, the right, the bottom, and the left. Okay. So there's going to be like 4 areas where we're going to put dots, and that's just a way to show clarity and to keep it from getting too messy. And the other thing is, this might be something that you remember from shell models, but we don't want to pair electrons until we have to. And so in the shell model, it wasn't that big of a deal if you ended up pairing the electrons. It was okay. With Lewis symbols and Lewis structures, it's more difficult to do it if you start pairing them up too soon. Okay, so we want to make sure we're not pairing electrons until we have to. And so when we go through some examples, I'll show you what I mean by that. All right. So what I'm going to do now is I'm going to go through these 4 examples. Okay, so we're going to draw this Lewis dot symbols for each of these elements. Okay, so hydrogen, carbon, calcium, and oxygen. And so if we go over to our Jamboard, so what we want to do is we want to follow the formula, or follow the recipe that I gave you. And so the first one is hydrogen. Okay. And so what we want to do is we want to write the symbol for hydrogen, so H. Okay. And then we want to look at the periodic table and say, all right, how many valence electrons do we have? So if you remember, hydrogen is in the first column, the first group, so it's just going to have one valence electron. Okay. So it has one valence electron. Okay. And so again, we're going to write that valence electron as a dot. And so we only want to write it on the right, the top, the left, or the bottom. So I like to start on the right-hand side just because it's easiest for me because I'm right-handed. So we're just going to put a single dot there, and that's it. That's all you need to do. All right. So again, I put on the right-hand side. It doesn't matter. Okay. So if you put it on the top, the bottom, or the left, it doesn't matter. Okay. But since hydrogen just has one valence electron, all we do is we just put a single dot. All right. So our next one is carbon. All right. And so carbon, if we look at the periodic table, is in the fourth column. Okay, so it's in group 4A. And so what that tells us is that it has 4 valence electrons. All right, so we have our element, we have its valence electrons. So now we want to draw the symbol, which is C. And this is what I'm talking about when I say we don't want to pair up electrons. Okay. And so again, I'm going to start on the right-hand side, but I'm just going to write a single electron there, okay? And I'm going to go to the bottom and write a single electron there. The left, single electron. Top, single electron. All right? And so what I mean by not pairing up electrons is you might see that this, and you're like, okay, I have 4 valence electrons, so you might do something like this. Okay, we do not want to do that. And right now, it might not seem like a big deal, but over the next couple days, we'll see why we don't want to do that. All right. So we want to make sure that we're not pairing up these electrons until we have to. All right. And so I forgot the order. So the next one is calcium. Okay. So here we have calcium. And so if you look at calcium, it's in group 2A, so it's going to have 2 valence electrons. All right. So if it has 2 valence electrons, we're going to have 2 dots on our dot structure, dot symbol. Okay. So again, we want to write our element name or our element symbol, which is calcium for Ca for calcium. Okay. And then we have 2 valence electrons. Again, I'm going to start on the right-hand side. So I put 1 there, and then put 1 on the bottom. All right. So it doesn't matter. Okay, you can do something like this. Okay, you can do something like that. All right, all those are fine. The only thing that I don't want you to do is that. Okay, so I don't want you to put 2 electrons together. So do not do this. All right, the rest of them are fine. Okay, so it doesn't matter, if you put on the top, the bottom, the left, whatever. As long as you have 2 single electrons, I'm fine with it. All right. So hopefully you're kind of getting the hang of this. The last one is oxygen. Okay, so if we look at oxygen, it's in group 6A. Okay, and so since it's in group 6A, it's going to have 6 valence electrons. All right, so now we're going to draw our symbol, which is O. For this one, we'll start like we have. Okay, so we're going to draw single electrons. So now we have a single electron in each location. All right, but notice we only have 4 electrons right now. We only have 4 dots, and we have 6 total. So since we only have 4, we still have 2 more left. So this is what I mean when I say don't pair them unless you have to. Okay, as soon as we get up to 4, now we have to start pairing things, right? Because we can only have 4 locations where we can put electrons, and we can have up to 8 electrons. And so we have 2 remaining, so we'll put a second one here and a second one here. All right, so now we have 2 locations that have 2 electrons, and then 2 locations that have just 1. Okay, again, it doesn't matter where you put them, so it's equally fine to put something like this. Okay, so those are both acceptable. The one thing that I do not want you to do, okay, is something like this. Okay, so don't put 3 electrons or something like that. Okay, so don't do that. So we can only have up to 2 electrons in each location, and again, we don't want to pair them until we have to. All right, so your homework is just going to be, there's 10 elements. You can go through and you can write the Lewis symbols for each of them, okay? So I know that if you Google, oxygen Lewis symbol on the internet, it will give you it. So I would recommend you don't do that, okay? So if you know how to do this, it's going to be a lot easier to do the more difficult ones that we're going to down the road. So right now, this might seem really easy. You're like, okay, why are we doing this? But as we get a couple days from now, we're going to do more difficult ones, and so it's going to be crucial that you know how to do this, all right? So again, that will be your homework. We'll just do that worksheet on a separate sheet of paper.